All right, quick audio check here. Hopefully you can hear me okay. I will be popping back in just a couple minutes, getting set up. Hi, everybody. I don't know if to say good morning, good afternoon. It's 12:05 p.m. Eastern Time here in the state of New York in these United States. And this is my weekly Monday stream of the Coding Train. Nice to see all of you. I don't really know entirely what I'm going to do today. I would love to hear from those of you in the chat where you're watching from. That's always something that I enjoy. I am my third week in now into the fall where I have been streaming every week. The goal of these streams is to cover a variety of different topics, and then later on in the week and into the next week, as I will explain in a second, various parts of the stream will then get edited and released as regular uploads onto the Coding Train YouTube channel, which is the channel that you're watching. So first of all, let me introduce myself. My name is Dan Schiffman. I have been doing this Coding Train thing on YouTube for well over 10 years, and it's kind of ebbed and flowed, and I don't really know where it is right now, to be totally frank. Although I'm not Frank, as I said, my name is Dan. But I'm trying to figure that out this fall. So the last couple streams, the first stream was an extreme mess. And I covered Bayesian text classification. There is an edited version of that that will come out sometime, I think, in the next couple weeks. Again, I mentioned this last week. If anybody is, I'm sorry, I'm trying to keep an eye on the chat as well. Hello to many of you. Special shout out to Deepam, who has just given me an extraordinary amount of help in the last couple of weeks in the Discord, answering questions and reviewing various things that I've been covering. What was I saying? So the first week, Bayesian text classification. Oh, yes. If anyone has any particular expertise or watched that live stream and is especially curious, please pop into the Coding Train Discord if you would like to help give feedback on that edited version, fact check it. I see we've got Zenova again in the chat, which might lean me towards covering some Transformers.js today. Okay, so Bayesian text classification, that was the stream from 2 weeks ago. Last week, I did a double stream, which is what I would like to do on Mondays. I don't think that's, it's already noon, and I have a lot going on. I had a busy family weekend, which caused me to get into the location where I'm doing these streams later, and I'm more unprepared than usual. Not that I've been very prepared the last couple of weeks, but I'm really just walking in here, turning the lights on. And so I'm a little bit more out of sorts. So last week, though, okay, what did I cover last week? Oh, you're not even seeing anything on my screen, which doesn't really matter right now. But let's wander over to Ye Old Coding Train YouTube channel, who apparently is live right now. I'm not signed into YouTube here, so this is just whatever. So this is what 84 of you are watching, which is kind of a small number, but totally fine. It's intimate. This is an intimate setting, just you and me here, which is good. Takes the pressure off here. But if I go here to live, I'm just curious here. Yes, we had, last week I covered the Transformers.js, as well as P5 2.0, async, and await. I'm kind of figuring out how to title these. I'm just using like default thumbnails. Could really use some help or ideas about how to best archive them. Although in the end, I think these are really meant to be watched in the moment. And if you're interested in the topic, you're probably better off watching the edited versions that will come out later. So maybe putting any time and energy into archiving these is not entirely necessary. Here is the Bayesian text classification. And I did have these like streams over the summer that I do think these two are in particular are worth going back and watching if you're interested. Okay, so that's what's been happening. Now, let me make you, oh no, that's not where I'm going here. Let's go over here. Let's make a little list here. So, edited videos. Hold on. Let's zoom out at this a little bit. It's a little bit too thick. Okay, hold on. Maybe I'm already, okay. Okay, what's coming out edited video-wise? So today, it's already ready. I could even drop the link to the unlisted version of this video in the chat. The P5.2 async and await video is coming out. And then there is also another async await video. I still have this problem with this pen. So those are in the pipeline. This one is ready. This one is almost ready. We've got, I believe, intro to, and I'm just going to write tf.js. These days, I think if you hear me or see the label tf.js, I am almost definitely referring to Transformers.js. Maybe there's a better abbreviation. This is a very confusing abbreviation because there also is a library called TensorFlow.js, which could be abbreviated with TF and also happens to be a machine learning library. So there's that, and then there is the LLM video, and then the Bayesian text classification. So I think one thing just to sort of like mention here, I'm just kind of being accountable to myself and trying to figure out this system, is that I've done 2 weeks of live streams with all of these topics, none of which are the edited videos actually out on the channel yet. So a lot of that has to do with figuring out the processes of how to deal with the files and get them uploaded, and Mathieu's working on them. So, so this is something that Mathieu and I are collaborating and thinking about, but it is kind of also a reason to just have a little bit of a, let me slow down and do a bit of a planning stream, do some Q&A, cover some random stuff today to allow us some time to kind of catch up on these videos. So stay tuned for that. Okay, coming back over here. Checking the chat. I'm looking at these wonderful people coming from Indonesia, and I'm scrolling back, and I see India and Saudi Arabia, the Netherlands. Amazing. So wonderful to be here on the internet with all of you today. I'm trying also to just have a little bit more of a calm energy because I think sometimes I get to these streams and I'm like, I'm raring to go. And then I like blast through all this energy in the first 10 or 15 minutes. And like, these are kind of long, so I need to sort of save myself. And this makes me very happy. This is kind of what I'm going for. This comment from Yuvaraj, who says, Mondays are now becoming exciting because of your live stream. Here's also just a small little note. I really should just schedule these, put them on YouTube and have them scheduled. But what happens to me is I'm like, I'm not sure what time is going to work right for me, because sometimes I have like a quick Zoom meeting I have to do, or so I end up not scheduling these until like Monday morning, and I just like throw it up on YouTube. I don't know. Kekev says, hey, I got an idea. How about coding today? All right. So this is a very, very important comment, and I would like to do some coding today. So let's go back over to the whiteboard, and I would like to kind of tell you a bit about my thinking about the topics I'm hoping to do. I was going to say in the next couple weeks, but really I'm kind of talking about this semester. I think I'm looking, the coding train, my current kind of plan for the coding train is to treat it as something very seasonal. So we're going to do a fall semester, we're going to do a spring semester. There's probably going to be like a winter break. So I think one thing that I discovered is I think in doing this is if I commit, it's much better for me to commit to some time and kind of have that planned. The lawnmowers have begun. I'm going to talk about the lawnmower in a second. Oh boy, it's so funny to me. Okay, but it's much better for me to commit. And then have planned times where I'm not streaming or recording, than just kind of like always feel like I should be doing it and trying to fit it in and squeeze it in. So right now, every Monday. I will say that most likely so next Monday I'll be here. I think it's whatever is the holiday here in the US, Indigenous Peoples Day, on Monday. I think it's the 13th, the 12th, 11th, I can't remember. I think I probably won't be here that day. It's a holiday, my kids don't have school, and I don't know what the family plan will be. So there will be some Mondays that I miss, maybe Thanksgiving week, I don't know. I'm sure I was sick actually the week that I did the Bayesian text classification, which maybe is my excuse, one of my excuses for why that didn't go very well. Okay. All right, but let's talk this through. So there's a couple categories here. Here are my categories. P5-2, P5 beginner. This is actually, and then what I would say is ML. And again, I'm allergic to the letters AI, even though that's kind of what I mean. But I want to really focus on it being machine learning. So these are kind of what I'm thinking right now. P5-2, we've covered async and await. That's done. I want to cover, probably should cover variable fonts. And font outline. I don't know what to call this. The outline of the font, the sort of like vertices of the letter form, font geometry, maybe I would say. I want to cover custom shapes changes, in particular splines. So that's my list of P5-2. Okay, so there's a loud lawnmower mowing around here. I am at a residence, which happens to be my residence, but things are kind of complicated because I'm in the process of moving. And I don't mow my own lawn, as might shock you here. And the mowers that I have hired, they come on Mondays, and I tried to reschedule it, but there was no other day. But then I sort of thought the plan was to have them come like really early in the morning. So that's why also I delayed a little bit today. But then they weren't here. I was like, oh, maybe I'm confused. Anyway, of course, Murphy's Law, whenever I start streaming, the lawnmower starts. There's also, I don't know if there's like a hive somewhere hiding. I'm in a garage and there's a little attic crawl space above, but there's like 3 or 4 bees. No, 1, 2, 3, 4, 5, and they're all by the sort of like window over there trying to get out. So I gotta figure that out. I'm a little, this space was not meant to be my recording space this fall, but life gets in the way, and I pressed the wrong button again. Okay, that's enough of these personal tidbits. Okay, but this is good. This planning stuff is fine when the lawnmower finishes. Okay, P5 beginner. This is really, I'm just going to make the list. Basics, variation, conditionals, loops, arrays, functions. This is my new kind of order. Objects. So because there's a new P5.2, I want to redo all of my beginner tutorials. However, if I were to mark some of them, maybe with a highlighter, let's try this highlighter. I haven't tried this before. And actually, let's go over to the computer for a second, because this will help us. The thing about the lawnmower is it causes me to speak much more loudly, because I think I got to shout over it. I don't think you all hear it. I think I might have noise reduction. I know the noise reduction is getting rid of it. It's more just an issue for me. Okay, so if I go to the Coding Train website, and I go to tracks, and go to here, this is what I'm talking about, which is redoing this series. But if you look at it, this needs a refresh because the web editor has changed a bit, but it's really fine. This kind of is mostly fine. It's using the web editor. Fine, fine. All this stuff still applies. Once I get to here, these I redid. I don't know about these thumbnails, although I kind of actually really like them. Random map. Oh, ancient video. See, here we go. The map video. Though, to be honest, like, what's the point of redoing that? The concept of map and everything about it has not changed. So that it's not too high. I don't know why I create graphics in here, but I always feel like it comes up. So I made this extra video and put it here. But let's look here. Aha, here we go. I really feel like these should be redone. They're the oldest. So redoing those might make the most sense. Let's go back over here and see if my highlighter works. So under variation, conditionals. Oh no, variation we decided was not as big of an issue. So it's conditionals, I know loops, and I know arrays. And then, and functions. So these are the ones that are the most old because I redid objects whenever I decided, oh, ES6 classes is a thing. And then I redid the basics and variation a number of years ago. But I do think there's kind of like, I don't know what pen to use here. I'm kind of overdoing this. I teach arrays and functions quite differently now. And I think the video on functions uses like an object literal, and it's kind of confusing. It doesn't follow this trajectory really well. So these would be like sort of like priorities. So I kind of have this question in my mind of maybe I should just take if I could somehow have just like a few days free, I could just like run through all of it just in like 2 days streaming and then cut them up into little, or I could just take the approach of like slowly over time, out of order, let me redo a bunch of these topics. And certainly I'm not looking at the chat right now, but if there's any teachers or people who use my videos as part of their curriculum watching in the moment or later, please reach out to me. I would love to, if a certain way of doing this would be most helpful for you. But I think what I also have a little bit of a mental block on is I would like to, let me just get the black again here. I would like to do a new intro which covers history and then kind of talks about like why maybe you still want to learn with AI. So I really want to make that video. I actually wrote a script for it just as an exercise. I mean, it's a total mess. I couldn't just do it right now. And maybe it's worth talking through some of the ideas there and like in a live stream and but that's my plan. So these are things. Now, under the ML topic, there are some things. Mostly, I want to continue with TF.js, meaning Transformers.js. I would love to cover depth estimation, image segmentation, just making a list of things on my mind. I want to look at how you might do speech to text and text to speech. I can't decide if those should be like separate tutorials, one longer like coding challenge video where we just make a, hey, conversational chatbot, but let me just write these out. Text to speech, speech to text. Actually, hold on. Let's save myself some room. So those are things I want to cover. Actually, this is a little bit separate, and this is what I was thinking of doing today. I wanted to cover softmax, sampling, and temperature. Like, this is my idea for doing kind of a separate tutorial. So this is a little confusing here, but my idea for this is, one, I have these Markov chain examples that I've been using for years. And I'm also wandering into, as you saw earlier, looking at LLMs. Oh, and I have a question for Zenova if you're actually still watching, or if you just heard your name and popped back in. But I thought that like a separate video that just looks at, I have an array of things, and each thing has a score. So what is the math for softmax that allows me, and you might not know at all what I'm talking about. The point of this, I would explain this. But softmax is a mathematical function that gets used with neural networks in the last layer before the output is picked even for like image classification. You're just turning all these like positive and negative arbitrary score values into probabilities that all add up to 100%. So softmax does that. I've already actually made videos about how if you have a list of things, each with a probability, how you pick one randomly based on the probabilities. But what I haven't looked at is how you can then add this temperature variable to either stretch the probabilities so that the more likely ones are even more likely, or like flatten them, which could make your system a bit more chaotic. And that's the idea of temperature. Turning the temperature up, it's actually turning the temperature up flattens the probabilities. It's a little counterintuitive because you're making it hot. But the reason why it's hot is because you're picking crazy stuff that's like normally very unlikely. So that's actually what I was thinking of covering today. And I think this is mostly, I could keep going here because I want to do like object detection. Object detection is one. Image captioning. There's just so many things. Zenova could give us a list of all the most exciting things to try, the latest and greatest stuff. Oh my goodness, 100% this semester. I totally forgot. This actually is like embeddings. And this is something I could actually do, and like similarity, sentence similarity, all sorts of kind of stuff there. So I think this is my map of what I'm looking to do this fall. Incredibly organized here. Let me come back to the chat and get some feedback. One nice thing, I set up a new scene here so I can actually bring, this is my map, and I'm just standing in front of it. So let me leave this here and see if I could get some, feedback or thoughts. Zenova says, oh yeah. Oh, look at this. So I made this new scene And so once I put the comment thing on, it's just like this giant comment here. Let me fix that while I'm here. The other thing is like I really want to improve my setup, but okay. I don't know which topic you meant was useful. And I'm gonna just okay. Hold on. I like that Zenova is giving me positive feedback here on this. And now I like this. I like this comment as well. Let's bring this up. Combining it with a beautiful visualization that has temperature parameter slider would make it really interesting for students. Yeah, well, I'll show you the example that I have. So first of all, I don't think you're very likely to get a beautiful visualization out of me. You might get a visualization. What I do like about this is that it could, I'm reading the comments at the same time that I'm thinking, which never works very well for me. And I already forgot what I was saying. One of the things that I do here on the coding train is when I make a video and it ends up on my website, then people can submit their own versions of it. So the perfect thing is for me to explain it, show a sort of bare bones explanation and demonstration, and then people can make their own versions of it that have more interactivity, more visualization, that kind of thing. Okay. So many interesting thoughts here. All right, so let's do a little bit of let's see if I can get a poll going. So maybe that's what I should do. Maybe I should work on this idea of softmax, sampling, and temperature. And in fact, we could then tie it back to, could tie it back to the LLM example. So let me and this is where I had a question for Zenova. Let me bring that up. Steve Mold has a video with snake with water in P5. Tell me more about this, but later in the Discord maybe, because I don't want to get too distracted now. But if Steve Mold is using P5, I'm like a huge Steve Mold fan. I got to check that out. Okay. Oh, the other thing is I could continue. I forgot I could continue the lesson from last week on the LLM video that I made that just used small LM. I don't know how to say it. I could do another video where I actually explicitly show how you add streaming and a conversation history. So that might be worth actually doing just as like a part 3, 2, whatever, however I'm counting that stuff. So maybe I should focus on that, because then I could come back and explain softmax, sampling, and temperature, which leads me to my question. So maybe I'll just continue with that thread this week and not put any pressure on myself to go. I'm still trying to, I have working examples for text-to-speech and speech-to-text, but I'm still trying to figure out if there's a way that I can simplify them and use P5 sound better. So maybe, and I could work through that during the stream, but hold on. But I'm trying to come back to here. Yeah, so let's go. Let me get the code from last week, which is maybe not, is it this one? Is this what I wrote during the stream? Yeah, this is what I wrote. Who are you? And then we wait for it to load. It's ready. Okay, great. Okay, here's what I wanted to figure out. So where, let me move this over a little bit. Actually, and this is plenty of room to come more this way for me not covering the code. Great. And I could actually even move a little bit this way. Okay, what I wanted to figure out, I'm going to leave this, let me duplicate this, is where do I put is this actually the code? This is the code that I wrote last week. It must be, right? I think I put temperature. Oh, first of all, why did the system prompt I can't remember what the other problem with me doing this right now is I don't have the edited it would be really helpful to do any continuation once I have the edited version, which usually helps me realize the things that I missed, and then I can bring those up at the beginning of the next video. But anyway, let's go with this thought. K. Viekman has a great comment here. Maybe mention the connection to the Boltzmann distribution, which is why temperature shows up. I would love to mention that, but that would be something I would need to kind of research a little bit more. I don't know if you want to say a little bit more about that in the chat or point me to a link that might be a good reference. That would be great. But it's a great suggestion. Okay, I'm just trying to figure out where I put the temperature. So I think it's here. And well, making it bigger is not helping. Also, when I load this model, boy, does my browser, this is like basically the most expensive, newest MacBook you could get. And I feel like it's actually often when I'm like plugged into HDMI out and recording my screen that everything seems to die. But okay. I am using the bigger model, 1.7 billion parameters. Okay. I don't know why all of a sudden I have a cough. No issue at all before the stream. Hold on a second. Let me mute. I am not muted. Okay. I'm trying to figure out where to put the temperature. So, nope, that's not it. Or I clicked too soon. Okay, what if I were to make the temperature 2? See, I think this is exactly the same reply. Like, first of all, though these are my questions for Zenova. Oh, and the chat, I'm sorry, I'm not scrolling with it. Do sample true. Oh, wait. Sorry. I need to do sample true. Where? Okay. Do sample. So this I need to do. There we go. Okay. So max new tokens, do sample temperature. So without do sample, what's it doing? I mean, it has to sample, but can I like set a random seed? That's what I'm trying to figure out to reproduce the exact same result. The softmax. I'm just going to follow up on this. The softmax gives the probability of finding a physical system at a given energy level. Got it. So it's the same mathematical function as the I just trying to get the spelling here. Boltzmann distribution. Let me see if I can find a nice reference. A specific state. Got it. So yeah. Is softmax mentioned here? Yes, I see. Is related to the Boltzmann distribution. I don't know. It might be out of scope for what I'm doing, but it is a very nice, nice point there. Okay, but I'm going to remove the comment. So by default, it's greedy, so no multinomial sampling takes place. Layperson language, please. I mean, I think I understand what that means. In principle, temperature has no upper limit. That's correct. And that's why I want to show the math for it. I think this is what we're going to do today. You know, I think it's okay for me to just slowly get to things. Like this comes up in my class. I have no video that I can point to for people to, okay. So, but now what I want to see is if I change the temperature to 2, which is like should be very, very high. I can't tell. I can't fact check this. Okay, so let's try something. You are a frog who only ever says ribbit. Why will it not open? Do I have this open in another window? No, these are other things. So like open in some other window on some other computer. Let me just copy paste here. No, this is even a copy of it. Doesn't make any sense. You do this. Okay. Now I can save it. Let me try running this. There we go. Okay. Ribbit. I am a young frog. Ribbit, ribbit. Okay, so the system prompt is working. I wanted to double check that. And then what I wanted to sort of see is if, I'm going to lower the temperature. And I should obviously make this like a slider that I can control while I'm running this. There we go. So there's no history here. So we're seeing with 0.1 temperature, this is what I get. And with a temperature of 2, I'm trying to make extreme differences. I mean, I don't know, can we get a sense, can we get a sense of, demonstrating this effectively? I wonder if I give it like, how many are like kind of more of a task? Can we have it be wrong more often once we change the temperature? That's what I kind of want to demonstrate. Just do this. I mean, I can actually just take out the system prompt right now. Like just give it no system prompt. Oh, whoops. I forgot. Okay, so a temperature of, I guess just like 0.5. Let's do it. Okay. Okay. If you set the temperature to 0.00001, let's try that. 0001. Okay. And let me put this just in here, just as like a, okay, so let me run this. What's going to be a good demonstration? The word strawberry contains no letters that are not there in the word letter, so it doesn't exactly count as making a fruit name out of letters. Wow. Is that, let's run this again. And then, what? But this is not what I would expect with such a low temperature. This is maybe what I would expect with a high temperature, wouldn't you think? I mean, I can gloss over this in terms of I'm just trying to work this out in terms of going through the math and actually explaining it. I mean, these definitely feel like different responses. Even lower. What if I made it 0? You can't set the temperature to 0, can you? Like, it really should be the same, like with the lowest possible temperature, like the temperature basically being 0. It should be, I should get the same result every time, essentially. But I'm not seeing this paper. Like, I'm skeptical that I've actually put the variable in correctly. Like, I cannot detect any difference between, Okay. I mean, this is a good point. I wouldn't call it an awful LLM model. I think this small is a terrific model because it runs right there in the browser and you can use it for all sorts of creative things. I, but you can, so maybe this isn't the best, yeah, right, Zenova? I agree. Maybe this isn't the best demonstration. It also might be, could it be clamped behind the scenes? Like whatever, I don't know what layer of the library or the model could be actually not taking our raw value, but like constraining it to within a range. Let's actually, okay, let's do sample false. Let's make sure this is right. Okay, so this is good to see. This is a good thing for me to demonstrate, actually. Sampling versus not sampling, and then changing the temperature. Which, you know, I also could, like you're saying, I could use a different model. I do want to cover using Ollama as well. I could add this to my list. If I come back over here. I also want to look at, if I put it down here, Ollama. Okay, I think the mowing is done. So I think I can move towards making a yes. Right. I don't know if this could be the wrong spot for the temperature parameter. I just sort of assume it's there, and we've got the creator of Transformers.js in the chat. So I assume if I have it wrong, he would say something. Okay, so let's make this the topic for today. And, you know, worst case scenario, I think I'm struggling with, like, worst case scenario, this particular topic that I want to cover doesn't necessarily have to be edited down. It could just be a thing that I'm covering during the live stream, which I think is also like a path for the coding train at some point, which could be to more just focus on covering topics during live streams. But the thing is, like, they're very, I don't know. That's not what I'm trying today. All right, but, and if there's some time left over, maybe just to dip my toe in, maybe I would try redoing one of these or doing another look at like another P52 feature. Okay, so I've got to get a few things set up. The other thing is I don't know where these videos, you know, should live. I guess maybe it's time for a new track. This could use some reorganization, a lot of this stuff here. It's such a great system to have for the channel, but I feel like it's ballooned a bit, and I haven't like really been keeping it maintained. So I could really use help. That's the other thing I could do today is I could show people how the website works and actually make a track for the P52 videos, because I would love help from the community in maintaining the website. The website is a totally open source system that you can very easily, through just like Markdown and JSON files, contribute to and help maintain. And I would love more help from the community in doing that. Okay. Is Gemma available with Transformers.js? I don't remember. It is in the right spot. Probably something, let me just put this on the screen here. Probably something funky happening with the sampling at such low temperature, but for the most part, it should operate correctly with temperature 0.1. Yeah, let's just, it's the lighting, by the way. Shumi is making a comment, who's this guy here? No, it's the lighting in here really shows my gray hair. You just couldn't see it with the lighting. No, this is literally like 10 years ago. This is what happens to a person. Although I'm in much better shape than I was probably 10 years ago, because my exercise regimen is very strong these days. But boy, do I feel old sometimes. Maybe I should retire from YouTubing. What do you think? Everybody that was a thing for a while, and I was just instead I just like burnt out, petered out, and now I'm sort of back, but not really back. I don't know. Okay, let's accomplish something. It's already almost been an hour, and I think much past 2 o'clock. Not going to get very far. Okay, all right. Let me keep some things open. So this is something I need to have open because I'm going to refer to it. Do not need this open. What I do need is so I have this Markov chain video, and I don't know which one I want to refer to, but let's look at this. Let me just see what's going on here. Okay, hold on. Let me do some stuff here. First, oh boy, let's update to p5.2. Why not? We don't need DOM anymore. Let's go here. Okay, and then how did I do this? I think I did this. How do you make something everything? No, not star. There we go. But that was crazy. Turn the auto refresh on. Okay, great. Okay. Okay. No. And this is using an order of 2. I think this actually is not a good example for me to use. Wait, what's it loading? Oh, this is, I didn't realize how long that was. Where did this come from? I don't remember what text I used for this video. Let's go to the other one. Name generator. Right. Oh, this was me trying to rename the channel. Okay, this should work. I can't update this to p5.2 because that will cause loading problems. Oh, but you know what? Let me duplicate it. Part 2. You'll see why in a second I'm going to do this. Order 3. Await. No, async. Okay, make sure this still works. No, await. There we go. Oh, now I got, sorry, 2, p5.2, there we go. Let's change this to, so there we go. Great, okay. Oh, I forgot I have this comment on the screen still. Okay. Okay, I think we are now good. However, now let me go to, okay, so I have this example is what I'm essentially going to build. But I also need this video. Okay. Is this the one that I do? Oh, yeah. Okay. So actually, then I also need, sorry, I'm trying to figure out where I have this. Okay, in here, weighted selection. There we go. Okay. So here's my weighted selection function. I don't think I'm going to explain this again because I have it in Nature of Code, and I also have this video where I cover that algorithm. So, okay, references are, this is what I'm gonna be programming. So this is just kind of like, let me stick that over here. Well, I'll show you what this is. This is like a whole bunch of an object with key value pairs, so fruits with a score, and then I'm sampling them here according to their score, and then I can adjust the temperature. This is essentially what I want to build. And then apply it to look at how I can apply that to Markov chains. And in order to apply it to the Markov chain, which is this code. Okay, hold on. I need this code, Markov chain. Okay, so this I don't need. This is maybe a reference, but this I'm not going to look at today. This I don't need. Okay. So the main thing, though, that I need to do here is, all right, so one thing I need to do here, which I'll change, yeah, just look at this for a second. If we look at the Markov chain, it's showing me every 3-letter sequence, and let's look at like this one, for example, and everything that comes out after it. So what I need to do, though, to be able to do weighted sampling with, like what I do in the current Markov chain is I just pick randomly one of them, and it's more likely if it's in there a bunch of times. But what I actually need to do is count how many times each appears, because those are the scores, so that I can apply softmax and then temperature. Okay, let's see if anybody else has said anything. So I think I'm ready to go now. I have all the pieces of what I need. I don't understand where this video is going to live on the Coding Train website or in what playlist, but I guess it's just a standalone video now. And let me go over to the whiteboard. I want to absolutely keep this list, which is, why am I not signed in? Okay, that's weird. Sorry, everybody. For some reason, I'm not signed in. And in order to sign in, I probably need to do stuff that I don't want you to see. So I'm just going to, you can enjoy watching this sketch run for a minute while I sign in here to the vibe board. Wait, okay. Sign in. Okay. Oh, quick sign in with my, hold on. Apparently I can QR code sign in. So let me try that. I am signing in, just so you know, I haven't completely left you all. Oh my goodness. No, I don't want to install an app. Oh, jeez. This is so weird. I think my board got reset because I don't know if people remember last week. Sign in. Okay, this is working, I think. Last week I had an issue where the board was going to sleep. Your sign request is not permitted. This is so weird. What is going on? Okay, let me sign in using my. I mean, I should just deal with this later. I can figure out how to save stuff later. But let me just give this one more shot. Yep. Okay. This is working. But you're just going to have to wait a minute here. Terrible, terrible live streaming. Should put, oh, okay. Oh, my God. Help. DTS. Okay. All right, hold on. This is going to just take a minute here. All right, let's look at this. Okay. Almost there, everybody. Okay. Okay, just needs a two-factor. Okay. I believe I am now logged in to this board. Ah. But where's my thing that I did? Okay. Well. Okay. Well, I'm logged back into the board. But I see that filled up. Okay, I don't know why I lost my canvas from before. So well, I guess I can log back out and find it. It was such a nice list of all the things. Of course, it's captured forever in the recording of this video. But okay. All right. So I'm now going to attempt to cover this topic. And I have to think about how to, I did all this time deciding what I'm going to do, and now I have to think about how I'm going to do it. And I also have to remember that the point of what I'm doing here is not to make some sort of perfect, edited, scripted, succinct, concise, fully thought out, and perfectly explained video about everything you ever needed to know about Softmax and sampling, but to just cover it here with all of you in this moment, in this live stream together, and assume that a slightly edited, shorter version of that is a useful thing. And if it isn't, that's also fine. Always point people to the time code about now in the video. I can also, for Mathieu, I can press this add marker button, which will just save a little text file with time codes from the stream of every time I do that. Okay. I kind of want to make a little outline for myself, though, of what I'm going to talk about. So first, I'm going to remind people about the Markov chain. And its technique for sampling. Then I'm going to remind people about the nature of code, genetic algorithm, and the weighted sampling there. Then I'm going to connect this to modern LLMs and also other ML, like image classification, so that we can then learn about Softmax and then temperature. And we will finish with some kind of example that does something like this, basically. Okay? How's everybody feel about that as my plan? And then we'll see where we are. Hopefully this won't be more than, I mean, in theory, the idea is for this to be like a 10 to 15 minute like video at the most. I mean, this could be like a 5-minute video just to explain it. But that's just not what I do. But I'm thinking this might take me an hour to sort of like muddle my way through. Okay. I'm just trying to decide if I want to start at the whiteboard or start here and what to show first exactly. All right. Oh, this also is an excellent post from, it's from 2020? March 1, 2020. What an auspicious date. But this also, greedy, right, highest probability. Oh, it's greedy without the do sample. Ah, I see. I see. Okay. Wow, I should really read this post before I make this video. Just looking through it to see if there's any other good references here. Sampling, yes. Probabilistic do sample true. Deactivate top K sampling. Oh yeah, I should cover also what top K and top P are. So top K. Oh, look, we'll just get an AI overview. That'll restricts the token selection to the K most probable next tokens. So without do sample, it's the equivalent of top K is 1, right? You're just picking the top K. Okay, are we going to get a nice top P here explanation? Top P is, this is like, you could change top P instead of temperatures from what I understand. Diversity of generated text by setting a cumulative probability threshold. Oh. So it's like top K, but the threshold, right, low top P and high temperature. Create a mix of common and slightly less common words. Balancing predict. I don't really understand that. Okay, top 1, consider all tokens. Top P 0. The single greedy decoding. So a top K, a top P of 0 is greedy, and a top K of 1 is also greedy. And as you do, so 0.1 is only, so top P and top K are the same kind of idea. It's just top K is like actually counting how many options will we pick, and top P is what's the probability threshold for which we will consider it an option. And it's kind of like inverted. Like 0 is only like the single most probable token. Oh, it's not actually a threshold. You're taking 90%. Oh, thank you. Don't worry, Raj. I'm going to have that list, no problem. And I'm sure if I sign back out of the account I signed into, it would be there and I could get it again. So I'll figure that out. Okay. It is generally recommended to adjust either top P or temperature, but not both, right? That makes sense. Okay. Decrease top P for a while. Yeah, interesting. Okay. Okay. Possible next tokens. Top P involves sorting these tokens by probability in descending order and summing their probabilities until a cumulative total is reached. Now then considers this the nucleus or subset. Got it. I still don't understand exactly. What it means. But so you sum up all the probabilities, and if those probabilities so why would 0 give you only the most? So, and 1, Oh, I see. Once you start with the top one, you add it to the sum. Once it's above the threshold, you stop. So you would only get to 1 if you add them all together. Got it. That's actually how the way the sampling algorithm works. Okay. Okay, I think I understand these things. I kind of hate, I hate that this reference for the video has this. Oh, I know how I can do this though. If I want this in the background, I can just have it like paused. Okay, that's fine. So I can reference the video without having that like crazy looking thumbnail. Okay. Oh, and actually, this is kind of the one that I am using the example from. Okay, I made some notes about Softmax. I wrote out all these notes in a notebook, and I didn't bring that notebook with me. Here, did I? No. I'm tempted to take a 5-minute break and go back to get that notebook where I have all the. I wrote out all the formulas last week. I was teaching this. The lawnmower's still going. Let's take a 5-minute break, everybody. I know this is really annoying for those of you watching, but I'm going to run and grab that notebook so that I have those notes with the different formulas in them, if that's okay with you all. So I'm going to put this. Oh, sorry, I was muted. How long was I muted? Sorry, I'm going to take a 5-minute break. Music's running. I'll be right back. I'm going to grab that notebook, okay? Okay, I am back. And I brought my other notebooks. But I don't know what page or where, so hold on, give me a second. I think it's in these. I wouldn't be in this one. I don't think I was using this notebook last week. Okay. There's also this one. This is so confusing. Too many notebooks. All right, I think this one I determined was no good. It should be in here somewhere. Okay. Ah, yes, here we go. Yeah, okay. Actually, I barely put anything in this notebook, but I went all the way back to, I guess you can't, the lighting in here is to get this. Okay, but it's fine. That's a nice reference for me to have. There. Okay. Look at me. I'm just like procrastinating because, but let's do this. This is going to be great. Okay. I'm just going to get these two pieces of paper. Okay. I'm going to end up looking up the Wikipedia page for these formulas anyway. All right. All right. So, the other thing I just want to mention to everyone, because it's a little bit confusing if you haven't watched one of my live streams before, is I'm about to go into, I'm recording a video mode. So I'm going to like pretend as if like nothing we talked about for the last hour and 15 minutes happened. So, and Chris Flannery, who says, I just got here. Well, I think your timing is perfect, really. You might be interested in all of the chit chat and other stuff that I talked about for the last hour, but I'm going to get into today's coding topic and start to work on it now. All right. I lost, by the way, I took that 5-minute break and I lost like 30 viewers, which is fine. Let's gain them back. Hey, everybody, tell everybody around the world that Dan Schiffman live on YouTube is going to sort of kind of mostly explain what Softmax is. I think the entire world is going to want to tune in for this. The numbers are going to go through the roof. Okay. All right. I think I might actually, well, I'm going to start here, and then I might move very quickly over to the whiteboard. Because I have an idea of what let me just, I know, I'm like refusing to start, but just give me a second here. Open, just give me a second here, oops. How do I get to all the ones I had last time? No. How do I get to, what's this do? No. Oh, I figured out some weird stuff that I can actually open up like P5 sketches here and like annotate them. But how do I get to all of my other, yeah, here we go. I was just sort of like, trying to see if any of the things, like this is what I was talking about last time. Oh no, it's like, this looks similar, but that was, okay. So, all right. Okay. Okay. All right, I'm just going to do it. Will I bring back coding challenges? Yes. Yes. Maybe that's just what I don't know. Yes, I would like to. Okay. Hi, everyone. In today's video, I am going to be covering a topic. See, this is my problem. This is my problem. I refuse to like just allow myself to just do this. What I really should do is just record like an intro later after, but it's okay. I'm adding a marker for Mathieu. Oh, and I'm in the wrong view. Okay. The lawnmower. Let me just see where it is. It's okay. All right, here we go. 120. We're gonna talk about this for the next 40 minutes. My viewers came back. I know, the wrong camera. It's okay, everyone. I'm gonna figure out the wrong camera in like 10 seconds in your time. I cannot believe the comedy of errors that is the lawn mowing and my video recording, which happen very, very infrequently. Like one day a week and only within a like 2-hour period on that day. And yet somehow, no matter what I do, those two things happen at the same time. Okay, but we're going to be fine. Hi, everyone. Today I am covering a topic that connects to a bunch of different themes and things that I've been covering on this channel for a number of years. And see, you can't hear it? It just like, it got really loud there for a second. Okay, Luke says he can't hear the mower. See, and then I say like, and I pause and I get worried and no. All right, everybody, I don't like the origin of this, but it is very, very appropriate right now. We're doing it live, people. We're doing it live. I scared myself with how aggressive that got. You know what I need to do? This is what we need to do, everybody. This is going to make it okay. It's time for to read some random numbers. Which last time I did this, I don't know when this was. Do we have some like relaxing music that will work with this? Oh, that's a nice little sound effect. 33007. Oh my God, so loud. We're just gonna have to wait till this guy finishes. 65578. Let's see how many viewers I lose when I read just live streaming reading random numbers. I think it's better if the book is much more visible. 42867. 12048. 60244. 57592. 26354. 38251. 43065. 61222. 48416 3417 36 0635 70352 87868 95894. Some people do deep breathing. Other people read from a random number book. Like, you know, you're all addicted to TikTok, I can only assume. You should get yourself one of these books and just read it quietly to yourself. I like how the viewer number, I'm like watching the viewer numbers, I'm doing this and it's going up. 96734, 20733, 40957, 544, 40 90488 67496 77673. Okay. I hear the dulcet sounds of the mowing off in the distance. Corey says looking for the audiobook. I have been threatening to make an audiobook for this. It would be very, very long. We could also automate it. That would be a good 11. Actually, that's a really good 11 Labs project with my voice clone. that I could do. Oh, that's also, I don't, yeah. Okay. All right. I think I can get going now. Hi, everyone. Today I'm looking at something called Softmax, temperature, weighted sampling, top P, top K, all of these terms that have to do with, well, in particular, they're probably most relevant these days, or where you hear them the most, is how does a large language model pick the next token, pick whatever it's going to say? How does that process work? It's some type of, there's some kind of like statistical model of language with probabilities, train a Dan, as a ton of Dashel says. I know, I'm just like, I don't know what I'm doing here. Wait, let's press the marker. I didn't start, if I press the marker, then Mathieu won't know that I did this a few times. Because I'll tell him, just go to the last marker. And I meant to be in this view, because this is what is best for recording. All right. This is confusing because I don't understand like the context of this video of what I'm talking about. But here's my commitment. I could always go back and record a hello, this is what this video is afterwards. So let me just get started. Hi, everyone. Today I'm covering a topic that interconnects to a whole bunch of things I've been doing on my channel. But the reason why, and I'm looking for my marker here, the reason why I want to cover it in this video is because I'm starting to work with language models. I recently made a video that shows you how to load a language model called small-lm. This model is compatible with JavaScript and runs locally right in the browser. And we can do things like prompt the model. Let's say I were to prompt the model with just one word. This is the input to the model. Now, what you might expect to come afterwards maybe is the word hello, or Dan, or how. Maybe it's going to say, hello, how are you? I don't know. It's going to complete your initial sequence of text with other text based on some set of probabilities. That's not what I wanted to say. I'm just doing a bunch of different things here to get myself into this. It's fine. And I press the stupid like button again, which creates new pages. There we go. Okay. So usually if you're working with a language model, you're probably prompting it with a sentence, a paragraph, a lot of stuff. But just to simplify things, imagine if you're asking it to fill in a blank. Hello, blank. What might come out? Well, maybe what might come out is the word, What might come out is the word world. Maybe what might come out is the word how. I wonder if a better example would make more sense, like hello, how are, I don't know. See, this is where I get in my head here. Should plan these videos more. I don't know if anybody has an idea for, is this scenario, how's this scenario so far? Okay, there's very little going on in the chat that I just checked. That's fine, I'm gonna keep going with this. Maybe the model somehow knows who I am. Maybe it's gonna say Dan. And if you've ever worked with a language model before, you might notice that even with the same prompt, you don't get the exact same output every single time. That's because what a language model is actually predicting is it's predicting. That's because, yes, the language model, what it's doing is predicting the next token, or an oversimplified way of thinking of it is the next word. It's selecting from a map of probabilities. It's selecting from a table of probabilities. Maybe world is picked 80% of the time. How is picked 15% of the time. Dan is picked 5% of the time. I'm thinking maybe world is 80%, how is 15%, Dan is 5%. That's what the neural network architecture is doing. It's encoding the input text, and maybe I'll come back and do a deeper dive into some of these pieces in another video, processing it through the neural network, and the output of the neural network is a giant table of all the possible next tokens in its vocabulary, along with probabilities. So the question, this begs the question, how are these probabilities calculated? And then why would you sometimes why would you sometimes want to adjust these probabilities? Maybe you want to flatten them to make maybe you want to flatten them to make different words. Maybe you want to flatten them to make the lower probability words higher probability, and we're just editing this video a lot today. It's fine. Maybe you want to flatten them so that the lower probability words, again, I'm just conflating the concept of a token and a word. I don't like how I just am glossing over that, although this is not a full LLM explainer. I think that's fine. Maybe the lower level maybe you want I could always record a correction for this later too. Maybe the lower probability words you want to be even more likely. I don't even forgot what I was there. Maybe you want like magic. This is not the most important point. Maybe you want to flatten the probability so that the lower probability words like Dan actually have a higher chance of being picked and the higher probability ones have a lower. Or maybe you want to stretch the probability so that world is even more likely than 80%. This is what I'm going to talk about. This is a concept known as temperature. Oh, geez. So these are the things that I want to explain in these videos. So these are the things I want to explain in this video. Softmax being the mathematical operation that takes the output of a neural network and turns it into probabilities. And temperature being a property that can be applied mathematically to those probabilities to adjust them in one direction or the other. However, it's important to note that these concepts of softmax and temperature are not the exclusive domain of large language models. And that's where I want to travel back in time to many, many years ago, an old coding challenge on the coding train, Markov chains. Okay, we got through that somehow. Masu, this like warms my heart. I'm going to put it up on the screen to no end. And I'll tell you something. My kids are like older than yours, but not by much. But like, they were like, yes, I'm having the same experience, except instead of a baby to like an 11-year-old, it's like, remember they were like 6 and now they're 16. It's crazy. Yeah. Okay. And all right, so let's keep moving here. Okay. So possibly I'm not going to rehash the entire coding challenge of the Markov chain, but let me give you a quick high-level overview of what a Markov chain is, and let's look at the code example for it. I don't know why the timing of that was unfortunate. I'm not going to rehash the entire Markov chain coding challenge. You can go and watch that for yourself if you're interested. But let me give you a quick high-level overview of what's happening in it and talk about what I'm going to change to add the concepts of softmax and temperature to it. Okay. That's such a good reference, but all right. This wonderful post by Victor Powell, I think, does the best job explaining the core concept of a Markov chain. We have a system that has a number of possible states, maybe just 2 states, A and B, and it hops from one state to another based on probabilities. So in this case, A has a 50% chance of staying at A or switching to B, and B is the same. I could now I've changed the probability to be 90% likely to stay in A. And you can see how the behavior of the system changes. Markov chains can be used to study. I just got a message that I should. Oh, yeah. Oh, there's a Veritasium video, yeah. Markov chains can be used to study financial systems, weather systems, all sorts of systems where there are sequential events, where there's sequential data or sequential events, and you want to investigate predicting the future or analyzing the sequence based on historical data. That's probably enough. A Markov chain can also be a language model. A Markov chain can also be a language model. A word or a token can be considered a state. The current state of the system is the word hello. What is the next word? Well, that's the same question as asking, what is the next state? So in a Markov chain, we might store a list of all of the words in our vocabulary, and then for every word, a table of probabilities for what could be the next word. If we execute that, and honestly, and really, a large language model is no different than a Markov chain. I mean, it's very different in lots of ways, but at its core, it's the same behavior. What is the current state, the input text? What comes next? The difference is, with a Markov chain, we're actually storing a giant spreadsheet, a giant table of all the probabilities. A large language model is using a neural network to estimate, essentially, all those probabilities. And you could not possibly load the same amount of data that you might train a large language model in with a Markov chain. But I digress. I'm kind of off. But I digress. I want you to make that connect. I digress. I mean, I think this is I digress. I mean, I think this is an important thing to think about. One of the beautiful things about using a Markov model for text is if you're asking the question, like, why did it say what it said? We can literally open the hood of the Markov chain and look at all the probabilities. When you're asking, why did this language model say what it said? Well, we don't really know. We have the weights of the neural network, and do we really know what data it was trained on? There's a lot more. There's a much bigger loss of that connection between the predicted text, the output text, and the input text. No. The predicted text, the output text, and the data that was actually used to drive those probabilities. Let me just sort of talk about that again, because I'm working through in my own mind what it is I'm talking about in this video. Yeah. Buildables gives a very good piece of feedback here, which is the hello is like a kind of bad example, but it's sort of too late unless I decide it's sort of too late. This video is what it is. This is me not thinking this stuff through. Also, this is way too much. Like, I kind of didn't, but it's fine. This is what I'm talking about today. A Markov chain is a language model. You can think of the current word in the language generator, or the input word here, hello, as the current state of the chain. I'm trying to start, look, I walked over here with an idea of what I was talking about, but now I'm in my head about the word hello versus the word I. Okay, I'm just going to keep, I'm like checking the chat. Like somebody will just tell me everything that I need to know to make this all make sense. Okay. I could actually replace LLM here with Markov model. Why? Because we could think of the input text to a Markov model as the current state. I have the word hello. That's the state of my system. The Markov model could then be holding the entire vocabulary, a table. The Markov model could then be holding a table of the entire vocabulary with probabilities for every word that might follow the word hello. This is one of the things I love about Markov chains. This is one of the things I love about Markov models. If I have a Markov model generating text for me and I'm wondering like why is it saying what it's saying, I can open the Markov model and look at the giant table of probabilities. This is very different than a large language model that is a neural network based system that's just estimating probabilities. It's been trained with massive amounts of data, and by the time you're using it, that data is so far away you can't make those connections anymore. That's actually all I wanted to say, so that's much better. However, with a Markov chain, a Markov model that's modeling text typically doesn't do it one word at a time. Is this what I was saying? Yeah. All right, let me say that over here. So whoops, this is not what I wanted to look at. I'm just going to close that. It's not what I want to look at either. Okay. Darek, I think that's a nice way of thinking about it. Yes. Okay, back to here. So this is my Markov chain that's generating new titles. So this is my Markov chain example, which I think was made so long ago. It was before I even called this channel the coding train. So I think it's trying to name the channel. Let's see what we get. Code red coding flock go. The sky. The code kitchenamino. I like that. I should be. I'm rebranding the channel, everybody. The code kitchenamo. So one important distinction is that a Markov model for text isn't typically looking at one word at a time. It looks at this concept known as an n-gram. Let's see if I can find that here. References, yeah. Well, this. Oh, this is actually great. I should have. This is actually a great. This is a great visualization that I should have used better than mine over there. Let's go back and forth between these. Let me come back from here. I'm just, yeah. So this, Mathieu, this is going to go before me looking at the code example. Be really fast. This is a really, who is this by? Chris Harrison. This is a really wonderful, okay, let me just. Let me do this. Let me just look at these. This is a really wonderful, is this of, oh yeah, Google's trigraph, yeah. This is a wonderful visualization of this idea by Chris Harrison. It's using data from Google Books. I think it's from Google Books. Okay. It's using data from a 2006 Google. It's using text from a 2006 Google data set and visualizing the frequency of words that come after the word I, for example. Have being most likely, am second, et cetera, and then further words after that. So that I think will be nice to include. Then I can come back to here, do this thing. I should also mention that if you watched, a Markov model for text, a Markov chain, doesn't typically consider just one word as the state. It usually looks at 2 words or 3 words or 4 words and tries to use that to predict what would be the next word. And in fact, in my example, I didn't even use words at all. This is a character level Markov chain, meaning it's looking at just sequences of 3 characters or 4 characters in a row and then creating a table of probabilities of what character would be next. Sequences of 2 words or 5 words, sequences of 3 words or 4 characters, those are known as n-grams, and the order being, those are known as n-grams, and the term order is usually applied to what is the value of n. Are we looking at collections of 3, of 4? That's the order. So in this code, you can see there's a variable called order, and then there is an array called there's a variable called order, and then there's this object called n-grams. in the console here, I'm logging the ngrams object. And you can see it is, okay, I should say that. It's a very small. So this demonstration loads just a text file with a very, very little text in it. I just realized I should add more stuff to this. But it's loading all of these names of what could be a YouTube coding channel. And then counting, how's it getting 48 instances of COD? I guess there are really 48 here? No. Oh, this is much longer. Okay, this is much longer. Sorry. Let me just do this. Okay. This example is loading this text file, which has all sorts of made-up names for what could be a name of a YouTube channel about coding, I guess. Then if we log that, then if we look at that ngrams object, we can see, okay. Then if we look at the ngrams object in the console, notice the order is 3. I have every single sequence of 3 characters, including spaces, all listed here. And for every one, like G space C, I have an array of all of the letters that come after it. So look at this. O appears 5 times. So why do I store O 5 times? I need a better example. Rainbows in there so many times. Yeah. Well, let's look at space CO. That has D, D, M, D, D. The D is there because the word code is coming after space C0. The D is there because there's so many instances of the word code or coding. M because the M is there from coding comrades. There's also an L. From where? Where do you see that? Where's the L? Oh, coding colors. And there's even an L from coding colors. Okay, so that's what I wanted to show there. Right. The Markov chain then generates text. Yeah. The Markov chain then generates text by looking at what the current state is and then sampling from all of the options of what could come next. I don't know why I closed this, because this is what I want. And where? Oh, yeah. And what my code does is it just what my code does, if the state is space CO, it picks from this big array randomly. So D is more likely to be picked because it's in the array many more times. This is a very crude and simplistic methodology that doesn't allow for This is a very crude and simplistic methodology that does. I want to go over to the whiteboard. I have it recording, but this is a very crude and simplistic methodology that doesn't allow for the concept of softmax and temperature to be able to adjust the behavior of the Markov chain itself. And I assume we'll edit out me wiping my nose. What is happening? Okay. I don't know. See, I didn't intend to like re-explain the whole Markov chain thing, but it sort of feels necessary to get into this. And I don't think people will have like watched the whole, anyway. So again, hopefully that gives you, again, that's the 2LDR of what the coding challenge was. I go and build this whole thing if you want to go watch that actual video. Okay. At the end of this video, I'm going to come back and update my Markov chain code to use softmax and temperature. But let's first just create a kind of dummy scenario where we can work out the math for these two algorithms. Okay, this is where I need some help. Should I create, this doesn't need to be in the video, I'll just make this up. I did like a fruit inventory thing, but I don't think that makes sense. I'm trying to think, I would love help from the chat here. I could call this like options, and I could make it an array that has like name, value, score. We could do, yeah, I could actually do like labels, because I could connect this to image classification, and I could do like name, cat, score, 13, like 2.3. I mean, I don't love this data structure, but like this is what I'm thinking. So like I could do something like this. Guess this is what for lack of a better idea. Oh, and this should not have the quotes around it. Okay, and there's a nice yeah. There's a nice, I covered this in, yeah. Where's the softmax? Oh, the whole point of... Right, the whole point of this is you don't apply this. Oh, right, this is the softmax. Yeah. I don't know if this is useful. Okay, I think I'll do this. Okay. Another place where you might have encountered the softmax function is if you've worked with the ML5. Another place where the softmax function has come up. Okay, I'm going to leave this here. I've most likely alluded to or talked about the softmax function in my image classification videos. I have several of those about working with ML5 and TensorFlow.js, as well as the teachable machine system. An image classifier will output a list of labels and probability scores for those labels. Oh, is this 90% cat, 9% dog, 1% turtle? But what a neural network actually outputs is not those probability scores. The output of a neural network is often referred to as the raw logits. This is a post about teachable machine, which I've covered extensively on my channel. And in this post, show this down here. Wait. Oh, yeah. If you give the image classifier this cat, if this image of a cat is passed into the image classifier, you get this giant spike in this visualization of all the probabilities all around different categories of cat. But the raw output of the neural network looks like this. This is the cat logits, the score, the unnormalized score, some value between 10 and -10 across all 1,000 labels that are part of this classification system. So how does it work to go from logits to probabilities? This is going to be such a long video, which was not my intention. I've lost so many viewers. It's fine. I'm working through this today. I'm learning. This is good for me. I'm gaining knowledge just trying to explain this and figure this out. But boy, did I just take like 20 minutes just to get to the part of like looking at the softmax. But I think it's going to move faster now. It's fine. Okay. Okay. So I have a kind of crude P5.js sketch with simulated output of a neural network. I have an array of labels that each has a name and a score. Now, one thing that I could do, let's just change this turtle score to 0.023. I'm going to write a quick algorithm to normalize all those scores. I can add up all the scores, I can add up all the scores into a sum, take every score, divide it by that sum, and I have normalized probabilities. 67%, 26%, and about 6%. So this would be one option, and certainly an option that I've used in other. So this is one way just to take any arbitrary scores and normalize them. It's not softmax, though. Why is this not? It's not softmax. And why is this not good enough? Well, one is neural networks will output negative numbers. So if I were to run this code again with a negative score, I get nonsense now in the probabilities. It doesn't work. And then the other note I made is, whoops. Wait, hold on, I just have to point this out. If anything, even if this stream does not get edited into a video, we have fixed a bug altogether in Transformers.js. There was, so I can update to 3.7.4 when I demonstrate that. And the temperature, I was trying to show this in class actually last week, and I was like, I can't figure out, make the temperature work. That's great, okay. So Kay Wiekman, just to give you a little bit more context, Znova is, yes, a developer on Transformers.js, but he's actually the person who created the library and essentially the main. I don't know how many other people are contributing to it, but it's all him. Okay. Okay. I would think here's my other question is the other reason for softmax. The other reason for softmax, which we'll get to the math in a second, but I'm just looking at the definition here from Wikipedia, it is that is an exponential function. So it's allowing for more possibilities of how you might adjust the relative scale of those probabilities. And you can see here, everything that I've said in this very, very long video is summarized in this one sentence. The softmax function is often used as the last activation function of a neural network to normalize the output to a probability distribution over predicted output classes. Let's now put the math into our code. We have to find the math. Let's see. Okay. All right, here it is. Yikes! Let's put this on the whiteboard and explain it. I need to be able to see this. Okay. I want to say, okay. All right. All right. Oh, whoops. No, that's not right. E to the Z I. I just don't know the notation. Oh, J. Ah, such a big eraser. That's what it should be, right? Yeah. Okay, now don't be alarmed. We're going to get through this together. It's actually very, very simple. Okay, we're going to get through this together. So first of all, this lowercase sigma, that's what that is, right? I got to look up Greek. So the problem is I have to get this right. It's lowercase, yeah. It's used for softmax. It's usually isn't that usually like sigmoid? That's the sigmoid function. I'm just trying to understand that. I know I just have the whiteboard over there. The standard unit softmax function. Usually sigma is for sigmoid. Right? So what's going on here? Maybe what I should do is just write this as softmax of every zi. I need some help with this. Why is this a sigma here? Is that just the label for that the Wikipedia page is using? I guess this is just using I know. Greek letter usage is overloaded. Oh, yeah, whoops. Thank you. I'm going to rewrite this out. I think I'm going to rewrite it, and I'm just going to say softmax of z. I think this is a better way to write it. Okay. Yeah. Okay. Okay. The Wikipedia page is using the sigma Greek letter to denote softmax, but I think it's a little clearer for me to write softmax. So what is z? Z is my array of raw score values, the logits. Where's my code that I'm writing? These values here. So let's put them. Oh, this is supposed to be a negative number. -3. I already forgot what they are. 2.3, 0.9, -3. All right. So for every I, this is really the softmax of any zi equals, so the softmax of any zi. So if we start with I equals 0, we're getting this value. And I'll talk about what E is in a second. E to the 2.3 value divided by the sum from, and I know I'm counting from 0 because it's an array, so the j equals 1. We could say j equals 0, but essentially we need to count through all of these and sum them together. So essentially, we're still just doing this whole elaborate looking formula. And if you missed it, this capital sigma, that's the Greek letter sigma, is the standard symbol for summation from 1 to k, or in the case of an array, 0, 1, and 2 indices. We're still just doing a sum of all the values and dividing each individual value by the sum to normalize across 0 to 100%. The difference is, instead of just summing the raw values, we're using the raw values as the exponent, e to the 2.3 power plus e to the 0.9 power plus e to the negative 3 power. Oh, shoot. I didn't press that button, which is fine. When did I not press the button? Never? What was the last thing that was in the, that you saw? Did you see me write the new softmax formula out or no? It's okay. I'm going to repeat this anyway. I guess I'm going to do the whole thing because who knows? Okay, I'm going to repeat the whole thing. You guys still haven't caught up to me in the real time? This is good because this is the heart of this. Okay, just check the chat. Oh, it was when I changed the sigma symbol. Okay, I didn't get the whole anything. Okay, hold on. Let me just do. I'm going to need some help explaining why we use E, but I guess as opposed to any other number. If anybody wants to offer me a short explanation in the chat or a reference. Okay, let me write this out. All right, let me write out the softmax formula here. Now, on the Wikipedia page, the notation looks a little different. It's using a Greek letter for softmax. But what I'm trying to show you here is softmax of any z equals, oh, and what's z? Right. Okay. Christian is saying when you introduce temperature, it's changing E. That's kind of where I'm going to. But why do we start with E? I guess. I mean, it's Euler's constant. It's the base of the natural logarithm. I guess it's just sort of like it's like a mathematical standard. It's a way that I'll kind of gloss over it. But where was I coming to here? Yeah. Okay. Z is the array of raw score values, the logits that are coming out of a neural network. Oh, I didn't press the button. I might have gotten these. I think these match the numbers in my code, but I'm not 100% sure. Hold on. Let me do that again, because I wrote them so big I don't have the right amount of room. So Z is an array with 1, 2, 3 values. So if we start with index 0, so I is 0, we've got the value 2.3. And I realize I'm saying the standard, I guess, way of notating it here would be from 1 to k, 1 to 3. But in coding, we use counting from 0. So just hopefully that's not going to be too confusing here. Let me keep going. So the softmax of 2.3 equals E. And let me say what E is in a minute. Just hold that thought. E to the 2.3 power divided by, okay, what does this mean? This is capital sigma, the Greek letter for summation. So we're going to sum from j equals 1 all the way through k, being there's k possibilities here, every single z value. So also e to the 2.3 plus e to the 0.9 plus e to the negative third power. And we're going to do this for every single one of these. Just make this a little nicer. Whoa, geez. God, this board. So in the end, we're still doing. So this is not that different than the standard normalization. You take the value and divide it by the sum of all the values. The difference is each value is the exponent to the equation e to that value. And just, hold on. Just looking up to make sure I'm right. Yeah. I'm just looking. You should also subtract max value from the logits before taking exponent, since exponent can be numerically unstable. Yeah, that's a good point. So I'll keep it. So, okay. Okay, so what is E? In truth, I could have put any number there instead of E. Okay, what E is Euler's. So what is E? Okay, let's point out a couple things. What is E? E is Euler's number. It's actually the base for the natural logarithm. Maybe this is just some mathematical word salad to you. I'll include some references in the video's description, but essentially you can think of it as a mathematical standard. What we're actually going to do is adjust what we're actually going to eventually do with temperature is adjust the value of E, but for now it's a starting point. The point is we need something to the exponent. What are 2.718? Yeah, that's what I was making. Euler's number, it's around 2.718, and it is like pi, an irrational number where the digits never repeat with any kind of pattern. This number is the base for the natural logarithm, so it's kind of like a standard in mathematics. There's lots more to say about it. I'll include some more references to Euler's number in the video's description. The point is more that we need to use these values as the exponent. That has this wonderful thing. What is e to... That has this wonderful quality of allowing for two things. One is negative numbers. E to the negative third power is the same as 1 over e to the third power. So with a negative number, we're getting a much, 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 much smaller value. And that will work. So everything becomes a positive number, but this value is really, really tiny, and it works well for probabilities. The other thing is because these are exponential functions, the higher the score, the greater the probability is. And this is something that we're going to get to tune based on changing what the base of this exponential function is. But let's at least go and put this into our code. Was that enough of an explanation? Did I get anything wrong? Adjust the value of E. Did I say adjust the value of E? I said adjust the value of E. Let me just correct myself. I just said adjust the value of E. That's not what I meant. E is just this value. I just said adjust the value of E. That's not what I meant. I mean adjust the value of the base of each one of these. I don't know what to call this. Adjust the value of the base in this equation. By the way, when you leave a comment, if you really need me to understand something that I got incorrect, you've got to provide a lot more context, just so you know. For this purpose, the meaning of E is not important. Okay, I'm going to keep going. It's 2:30. Holy smokes. What is wrong with me? Okay. Hopefully this is good. You all tell me later if you're learning something. Okay. Wait, what did I? Okay. Now you might be wondering, and guess what? Luckily for us, let me just make sure this is still in P5 too, because some of these like overloading of JavaScript functions, yeah. Okay. And guess what? Look at this. Right there in P5, we've got the exp function. Calculates the value of Euler's number raised to the power of a number. Perfect. So if I go back to my code, we already actually had the code for adding up all of the scores and dividing by the sum. All we need to do is add up all the scores as the exponent of e to the power of, and then divide the, and that's the new sum, and then add the exp function here as well. And now, even with the turtle having a score of -3, it's got a very, very low 0.3% or 0.4% probability. 20% about for dog and 80% about for cat. Okay, great. Okay, so I've now explained softmax, and we have it. To truly illustrate how this is working, I think we need to add the sampling to this sketch. All right, now I think to really demonstrate how this works, it would be important for us to have sampling added to this sketch, meaning pick one of the labels based on those probability scores, as well as some kind of visualization to show the frequency of how often those are being picked over time. Now, I'm already trying to do too many things in this one video, I think, kind of half explaining Markov chains and language models and then the softmax function and look at image classification. But hopefully this is interesting to you and you're following me somehow. Good news is I've already made an entire video about weighted selection, the sampling process. And I have covered this extensively in the Nature of Code book in both the chapter on randomness as well as my chapter on evolutionary computing, where we're picking parents in an evolutionary system based on their fitness scores. So I can actually take this weighted selection code and bring it into my sketch. But I can't help myself. Let me give you a very short overview of how this algorithm works before I adapt it into our code. Let's say we have the 3 labels and their probabilities. Again, our assumption here is these were all calculated via the softmax function. What if I visualized these probabilities in a rectangle? I don't know. I know where I'm going, but I don't know. It seems weird to say rectangle here, but that's what I'm doing. Now, imagine, okay, so we can see how this maps. Cat takes up 80%, dog takes up 15%, and turtle 5%. Now imagine I pick a random number between 0 and 1. That random number is going to land within here 80% of the time, and so on and so forth. That's essentially what I'm doing in the weighted selection function. It picks a random number. The funny thing about it is, how do you know where it lands? So the way that I do that is by starting by picking that random number and subtracting the probability scores from that number and seeing how many of those I have to subtract before I've left the rectangle, essentially gotten between, and I wrote this in the wrong way. So if we imagine I'm starting at 1 and I have to escape out of my algorithm, wow, the screen keeps moving. Escape. I think maybe I don't. I almost want to write it the other way, but. Oh, actually. I'm trying to like think about how I'm doing. I hate, okay. So if I pick a random number between 0 and 1, like let's say I pick 0.75, kind of land over here. If I subtract 0.8 from that, I'm already below 0. That means stick with cat. If I pick a random number to start with, where am I starting this race essentially? From down here, like 0.014. No. This makes no sense. It's the, okay. You know what? Okay, I have to do this again. I mean, I was fine when I just didn't try to explain the escaping thing. I should have just left it there. I'm just going to look at the chat for a second. Yeah, if the random number is less than or equal to cat, the choice is cat. If it's higher, add the next value in and check again. Yeah, that's the right way to explain it. Yeah. Let me just do this again because I've already like taken so long. I made a very hard long video here to edit. I'm like starting to sweat. I'm getting like verklempt here. I've already forgotten what I did. I lost my thought. I mean, I think I was fine whenever I was just picking what number between 0 and 1 kind of gets the idea. Keep. All right. I think there was a stopping point in there where I don't have to, I was trying to like do the other order, and I think I should just stop with where I was. I'm just going to explain it one more time more succinctly, but I don't remember. Okay, I'll just start. Actually, okay. I'll start from here. And I'm going to put the cat bigger in the bottom. Oh no, I just totally broke this pen. I mean, I didn't break it. It has these like tips, and I like broke the tip, which I could replace, but I think I should just get a different one. I won't use the fancy one. Okay. So now I can't press a button to change it, but that's okay. It's funny, now I'm doing it in reverse, but it doesn't really matter. Okay. So you can see here, I've drawn this rectangle with each section being scaled according to the probability value. Now imagine if I were to pick a value between 0 and 1. If I pick, 0.7, I'm going to get a cat. So 80% of the time, I'm going to pick a value that's within here, 15% of the time here, and 5% of the time here. That's essentially how my weighted selection function works. I'm going to leave it at that. Because right here, you can see I'm picking a starting point. Now, this is a little bit funny, but as long as start is greater than 0, subtract the fitness. Now, first of all, the fitness here, I'm going to change my code in a second. Actually, let me just rewrite this code to use the score values of this particular sketch. These are called labels. And I'm not actually using the score. I'm using the probability. And I'm going to say return labels index.name. Okay, once again, what's happening here? I pick a random number between 0 and 1. As long as that value is greater than 0, I'm going to keep going. And I start subtracting out the probability values and moving through that array. How many of those do I need to go through before I get below 0? Well, you can see if I picked 0.7 and I subtract 0.8, I'm already below 0, so pick the cat. By the way, the order of this doesn't matter. If I pick 0.7 and subtract 0.15, I'm still above 0. And then I subtract 0.05, I'm still above 0. It's only if I pick like 0.12 that I'm going to be out of the array. I guess the order does matter. Does the order matter? No, the order doesn't matter. The order doesn't matter. This will work out whatever order I'm doing. But I'm noticing if I were to pick 0.9 and subtract 0.8, I'd still be above 0. I'm at 0.1 and I go to subtract 0.15. Now I'm below 0, so pick dog. So I'm only going to get dog if this is the order, if I pick values greater than 0.8, and it would have to be greater than 0.95 for me to get turtle. Now, this algorithm always hurts my brain. So this should be a function that every time I run it, picks a random value from my labels array according to the probabilities. Let's add a draw function. Let's run this sketch and see what gets picked. Sorry, there's no I. The variable name in this function is index. So you can see, this isn't the best visualization, but you can see that cat is getting picked quite a bit more often than dog, and turtle comes up very, very rarely. Let's visualize this in a graph. let's give every label a count. And let's actually not return the name. I don't care about that. Let's just return the index. Then let's draw a graph with growing bars every time it's picked. So each bar will be, so the width of each bar is sized according to the width of the canvas. So the height of each bar is the number of times it was picked, count. So the y position, because I want it to grow from the bottom, is height minus h with height. And we'll give these a stroke of 0 and a fill of 127 and draw a white background. And I don't know what I was doing here, but I need to increase the count of the index that I pick every time. Great. Let's adjust those scores. We can see how turtle has never been picked. Or maybe it's been picked a couple times. But we could give turtle a higher score just to be sure this is working. And now we can see the probabilities have adjusted accordingly. Okay. Great. We're almost done, people. Woo! Almost done here. All right, temperature. Oh, my goodness. Where's that formula? Okay. I wasn't actually, the way that I do temperature, so you all were saying temperature is like adjusting the base, but the way that I do temperatures, divide the exponent by temperature. That's not really adjusting the base. That's just squeezing it's like adjusting the base, I guess. Why is it like adjusting the base? Because it's like saying, let me just work this out in another place for a second. So what I think is E is to the second power divided by temperature for a score of 2 versus like E is to the, let me make this, E is to the third power divided by temperature versus E to the second power divided by temperature. That's what I think of this. And what this is, so if the temperature were a 2, the temperature is 2, it's like saying E, obviously I could just divide it there, but I'm just saying it's like saying E to the third power divided by E squared. So it's like E to the 1 versus, It's not e to the 1, obviously. It's e to the 1.5, and then this is e to the 1. But that's not, that to me is adjusting the exponent. I don't think we're adjusting the base. Why is it like adjusting the base? Oh, you're not seeing me. I was over here. Let me think about this for a second. Oh, yeah, I'm totally wrong. I have become invisible. No, I got confused. Dividing by, because I got confused. I was talking about my brain is so melted. Yeah, what am I talking about? What am I even talking about? I'm just trying to scale down the exponent. I mean, it's very simple, temperature. Why did I think that? Because I got confused because it's like negative, because I was thinking about the negative before. So if is equivalent of scaling down the exponent is not really, can you consider that the equivalent of scaling down the base? Not really, I don't think. But anyway, I'm not going to worry about that. I'm just going to explain it. Let me come back to. I was here. Second here. Scaling down the exponent is the same as scaling down the base. The relationship between the operations just isn't linear. Yeah, that's kind of makes sense. Yeah. Okay. So yeah, okay. Okay. I think got it wrong earlier. I think I got it wrong earlier when I was talking about adjusting the value of E. But maybe I can cop to that a little bit. Okay. So this is where temperature comes in. What this equation allows us to do is basically dial up the amount one of the things that Softmax does by using the raw logits, the raw scores, as the exponent is it increases the difference between it. I'm so tired. I got to get through the end of this, though, because I'm basically at the end here. One of the things that the Softmax function does that we talked about earlier, beyond just allowing for negative numbers, is by using the raw score values as the exponent. Oh my God, the bee just landed right on the camera. It would be so cool if it crawled in front of the lens. All right, so One of the things that's wonderful about Softmax and is going to allow for temperature, this concept of temperature, is the fact that the raw scores, the logits, if you will, are used as the exponent. So one, we established that's great for having negative scores, but also because this is exponential, a higher score will lead to even higher probability. But what if we want that to be increased even more or turned down a bit? Well, all we would need to do is divide this. Oh no, undo that. All we would need to do, mysterious screen. All we would need to do is take this exponent, the exponent, very hard to say, and divide it by temperature. So a temperature of 1 will do absolutely nothing. And by the way, we're going to do it here as well, of course. The temperature of 1, so the temperature of 1 does nothing. A temperature of 2 has the result of making this exponential power less. So it's squashing those probabilities. They're going to get closer to each other. That's a hot temperature. We're turning up the temperature. If the probabilities are getting less, closer to each other, we're more likely to pick the weird and strange outliers. If the temperature is down, if you think of it's less than 1, 0.5, 0.1, obviously it can't be 0. You can't divide by 0. Then we are increasing that exponential power, and the cat is going to be even more likely to be picked. Let's look at how we add this mathematical property into our code and what it does to the end result. Okay. I'm just looking at the chat. Okay, I think. Did I do something wrong there? Let me know. I'm reading the backlog, but okay. So let me introduce a temperature of 1. Let me go and put turtle back to -3. I didn't bother to like package Softmax up into another function or think about anything at all. I'm just explaining the algorithm here. But I can now divide by temperature. And let's use a shorter variable named temp for temperature. There you go. A temperature of 1, we have the same result of frequencies that we started with. Temperature of 2. Look how more, look at, aha, look how dog is being picked more. That's the second one from left to right. And turtle's got a whole little bar there. Temperature of 5. Temperature of 1,000. I mean, at this point, I've squashed the probabilities so much, they're all even. At this point, I've squashed the probabilities so much, it's basically even probability. It's uniform probability distribution. Let's go back to a temperature below 1. 0.5. Yeah, looks like the dog is even less frequent, 0.1. There we go. We can see we're not even getting dog or turtle at all. Okay, that's softmax and temperature. Now, before I leave you, I want to go backwards and apply these concepts to both the Markov chain and a language model. Okay, so oh my goodness, this is going to involve some serious coding here. So I'm going to try to do this kind of quickly. Why is this I? Oh, I plus order. Okay. Okay. Okay, I'm going to do this quickly. It's a little out of scope for this video, but I'm going to update the Markov chain code to count the frequency of characters, not just add them to an array of options, which is what's happening right here. So we need to check. The next character is that next character. If n-grams that gram has never seen that next character before, then it should have a count of 1. Otherwise, we should increase its count. So this is me calculating scores for the next character, the frequency of next characters in my Markov model. Actually, I think it was, all I had to do was that. Let's look at the Markov model again. No, I missed something. Oh. If I had never seen that n-gram before, I made it an array. It needs to actually be an object. They're all not a number. What did I get wrong? Oh, if it hasn't seen it before, it gets a 1. Otherwise, it counts. There we go. Space CO, the next space CO, whenever that group of 3 characters appears, a D follows 19 times, an M once, an L once, and an S once. So these are, so now that I've built this model, these need to be converted into probability scores with Softmax. Oh. Options equal. I need to get the options for that n-gram, which is now an object again. And then I need to get then I need to do a for loop for C of object keys options. Sum equals 0. Sum plus equal exponent options of C. And then options of C equals exponent options of C divided by sum, right? This should be the algorithm that is looking at every n-gram. We'll call this a gram. I think that's kind of nicer. Every n-gram, these are the options that come after it. I sum up all of the counts to the exponent power, and then I just divide do the same thing. This is softmax. For constant key entries. Oh, I could do key. I can't use key. That always messes stuff up. But this is technically right? They could be improved. All right, let me just make sure this works. Oh, no, it won't. I don't have the sampling, so I think. So now, let me just look. Yeah, that's right. 99% D. Very small probability of those. Yeah. Okay, not the most elegant code, but now I have applied the softmax algorithm here. I am looking at every n-gram and all of the characters counts that come after it, and taking those character counts and passing them to the exponent function, e to the count, taking all those character counts and setting it as the exponent, e to the character count, summing that up, and then dividing e to the character count divided by that sum. And now you can see I've set the values to those probabilities. D has a 99.999% chance, MLS a much lower probability. Okay. Now what I need is now I need to grab this weighted selection function and bring it into the Markov chain. I think it would make much more sense for this function to receive an array as its argument. I'm going to assume that array, I called it options, but maybe it's probabilities. It's an array of probabilities, and it gives back the index, picking based on the raw value of the probabilities. So before, the previous code was just picking a random possibility from an array of many characters. So now this needs to be weighted selection and it's actually, and the possibilities array is the key value pairs of character probability. So I actually need to get the values out of that array. And then the character is the key. Clunky object-oriented code here that I don't expect will make a lot of sense to you, but not the sort of core aspect of this video. What's a better way to write this? Well, it's got to be a better way to write this. I should use the entries. Okay, I'm going to use the entries. This is where entries. Okay. So possibilities is the collection of key value pairs. Character probability, character probability. There's a wonderful JavaScript function called entries, which allows me to separate those key value pairs into two separate arrays. This means I want to perform the weighted selection of the values. Those are the probabilities. Hold on, I'm looking for the right syntax here. Oh, yeah, I think it's fine. The weighted selection of the values, those are the probabilities. I could actually call it that. And then this is the next index, and the next character is the key associated with that next index. So this is just me adjusting the sampling process to use the new probabilities that are calculated by Softmax. Let's see if this runs. Undefined. V1, that's right. What does this look like here? Oh. I'm so confused. What did I get wrong here? I just turned it into an array. What am I missing here? Oh. Oh, I see. I don't get two separate arrays. I get an array of arrays. That's not what I want. I see. That's not how it works. I'll have to think about this. I have to go back. Okay. Let me think about this. I mean, I could also just change the way this function works. Yeah, okay. I'm going to do it in an awkward way. I'm going to do it my own awkward way. However, so before, you go from here. Yeah, that's what Sachin is saying. That's what I'm going to do before. I'm just going to put those into separate variables. Okay. Now here is the sampling. Before, possibilities was just an array of all the characters with many characters multiple times. Now I need to pull the one based off of the weighted selection function, which gives me the index. Now I need to sample based off the weighted selection function, which is assuming an array of probabilities. So I'm going to say probs for probabilities is the values of the possibilities array, right? The possibilities array is now, the values of the possibilities, variable names are terrible. Possibilities, the possibilities object is now key value pairs, character probability. So I can get an array of all the probabilities with object.values and an array of all the characters with object.keys. So we sample from the probabilities, and the next character, the next index, that's what getting back is the character's next index. So this is the new sampling based off of that array of probabilities. And of course, there's other ways to organize the code and think about it, but this is just the way I'm doing it now. Ooh, undefined. What did I miss here? I don't see what I missed. Oh. Duh. Whoops. The whole point is I'm no longer using a random one. Weighted selection. That's going to give me the index. There we go. And finally, we can also add temperature back into this. And finally, we can now add temperature. Let's start with a temperature of 2 just to see something that feels maybe a little different than these names that were selected over there or generated over there. And again, let me call it temp for short. And here, remember, all we're doing is we're taking the raw scores and dividing by temperature. Appearing Unicoding Me, the new name for this channel. Okay. Live change this to version 4. Now, let's take a look at this in the context of a large language model. Here I have loaded in this model small to 1.7 billion parameters from Hugging Face, and I've loaded in this model, small version 2, 1.7 billion. I've loaded in this model, small version 2, 1.7 billion parameters from Hugging Face. You can see my other video where I go through how to use Transformers.js and load this model into a P5.js sketch. I've got the classic prompt that everyone loves to add their. I've got the classic prompt that everyone loves to ask their favorite large language model. How many R's in strawberry? Strawberries have 1 R in their spelling, which is definitely correct. Now, what happens, by the way, if I just pick? Now, what's going to happen if I submit? Now, what's going to happen if I press submit multiple times? I am getting the same exact response every single time. This is because the Transformers.js library with the text generation task, when you ask it to generate, by default, it actually doesn't do any sampling. It just looks for the single next token, the single next token with the highest probability. This is what's known as argmax. Don't bother to sample, just find the one with the highest value, pick that one every time. It's kind of like having a temperature of 0, essentially. You've stretched the... Oh. It's essentially equivalent to having a temperature of 0, by the way. You've stretched the probabilities so far that the highest one is 100% and everything is at 0. If I want the library to perform sampling, I need to add this property to my generate function. By the way, I called this pipe because I am getting the text generation pipeline, but I actually think it would be nicer to name this variable what it does, which we could call it like a generator. So now I'm awaiting generating the text, a maximum number of tokens, 128, based on these messages that have gone in. You can see I've commented out the system prompt, and I was doing some experiments with that, which you also might like to play with. Now I'm going to add do sample true. So now it will perform weighted sampling. Now you can see I'm getting wildly different responses each time. Let's lower the temperature. This is a little too hot for me. I can add another temperature property. I can add another property, temperature. Let's give it a fairly low temperature, 0.1. So we can see I'm still getting some variation, but notice the lack of the. So you can see I'm still getting some variation, but notice there's a more repeating pattern. There's maybe less variety here. I'm not getting the correct answer. That's a whole nother discussion that we could have about this particular model and this kind of query. But let's just turn the temperature way up. Let's make it pretty hot. Let's set it to 5. Now I'm just getting total nonsense because the actual probabilities that this neural network-based system is calculating based off its training data is almost gone. It's just giving me random stuff. It's actually kind of awesome, although I'm slightly afraid to go read it too closely. Did we get something offensive here that I have to redo this? I see an uh-oh in the chat, but I think I'm okay, right? Let's just throw in a slider so that we can adjust this in real time. In P5, you can make a slider with, I think you give it the initial value, then the range. Actually, I'm forgetting. I think it's the range, 0.1 to 2. Let's give an initial value of 1 and a step of 0.01. Actually, let's let the temperature go up to 4. So there's the slider. And then we can just get the value of the slider every time we do the query. We can have a low temperature. Wait a second. I might not have done this right. Let's look at the. Min max, yes. Did it right. Oh, I had the default value of 1. No. Turn it down. Oh, yeah. I don't know what I did before. Let's turn the slider down. We can see I'm getting this sort of like classic pattern with less variation. Turn the slider all the way up. And I'm getting something completely unrelated to my query, all about here berries, which sounds delicious. Since this video is already 100 years long, I should probably mention a couple other things. So we talked about softmax. We talked about temperature. Softmax being the mathematical function to calculate all of the probabilities based off of raw scores. Temperature being a way to squash or stretch those probabilities. But you'll also see terms like top K as well as top P. And these are kind of variations off of temperature. Not really variations, but they're also properties that allow you to adjust the way the sampling happens. Top K is actually the same thing in a way as argmax. So argmax is top K with a K of 1. But what top K does, if I had a K of 3 and I had 1,000 possibilities, I'm only going to pick from the top 3. So it's a way of allowing sampling to still happen, but reduce the number of possibilities to only the most common ones. So that's a property you could adjust also in the generate function, as well as top P, which is like top K, but instead of only picking the top N number, or top K, of options, you're picking only the options within a certain probability threshold. So maybe only the ones that add up to 50% of the top probabilities would be a way that you could adjust top P. But I probably wouldn't use... So for example, a top P of 50% would use... Well, in this case, it would only use world because it's already above 50%. But you could imagine taking all of the most frequent options and adding them all up. And as soon as you got above 50%, you stop and let all the other ones go to the wayside. Generally speaking, I'm just using temperature if I'm playing around with this stuff and trying to make creative applications with it. You might get confused if you start using top P along with temperature, though you absolutely could. But these are some different properties you could use to adjust the way the sampling behaves. Okay, have I said anything totally incorrect here? Because I'm wrapping this up. Poor Mathieu. I don't know if this will ever be a video. What else? Anything else I should say? All right, if you made it all the way to this video, congratulations, gold star for you. I don't know where this is going to live on the Coding Train website. Maybe in a playlist about Transformers.js and machine learning or somewhere else. But if it's there, I would love for you to submit anything that you make based off of watching this video. For example, there's so many ways you could create a much more dynamic visualization of the sampling process that I think would illustrate so much more about temperature and how it works than my like crude little graph thing that's drawing here. Maybe you could, oh, let me actually pull this up. Pull this up. Oh no, that's not what I was looking for. Not this one. Whoops. I have a version that I'll include that already has a temperature slider as well as a little bit nicer graph visualization of picking from a range of scores. I don't think I put Softmax in this one. I didn't actually use Softmax for this one, interestingly enough, but that's fine. You could make a much more dynamic and interesting visualization of taking a raw set of scores and turning that into taking a raw set of scores and applying weighted selection and adjusting with temperature. Here's a version that I'll share with you that just has a slider and a bit of fancier visualization, but you could probably do so much more than this, and I'd love to see that. You could probably be much more creative than this, and I'd love to see that. Well, right, the thing that I was looking for was actually Markov. I think I have this in here with, I'm gonna have to go to my, hold on. I thought I had one with weighted sampling. Oh, yeah. I do. Oh, I do. Yeah. This is with temperature. Yeah. But that's fine. I don't, yeah. Let me just. I also have a nicer version of the Markov chain with weighted selection and temperature that you could look at and be creative with. I also will include a nicer version that I've prepared with the, I'll also include a nicer version of the Markov chain that I've already prepared with the weighted selection function that takes temperature that you could use to maybe do something more creative and interesting. To do a more creative and interesting. Okay. I also have a nicer version. I also have a nicer, more cleaned up version of the Markov chain example with weighted selection and temperature. Maybe there's some type of creative visualization you could do to show how the Markov chain is building and picking new text, or you could load your own data into it in some creative way that I'd love to see. And then of course this could be so vastly improved in terms of the interface and behavior of how this particular hello world chatbot style. And then, of course, I'm sure there's so many creative and interesting improvements you could do off of this base Transformers.js language model with temperature example that I've made. So please let me know in the comments, did this video teach you something meaningful? I don't know anymore. And I hope you enjoyed it, and share with me what you make, and I'll see you next time on the Coding Train. Okay, that is the end of this monster of today. So much for my Q&A and going and doing like a P5 video. But, you know, I feel like this was important for me. I had to get some of these things out of my system. The Bayesian text thing, this thing. I've got to run. Oh, How have I been here for like 3 hours and 40 minutes? That's insane. I need a different process, but this is what's happening once a week. Zenova is still here. I don't know what time. It must be the middle of the night for you. But we did invent here berries. So that's something. Stamperia and Strombus being mentioned at long different definitions. Anyway. All right, I got to go. Did I miss anything super important? Robin, thank you for the nice comment. Thank you, everybody, for being here with me during all of this time. I'm going to do my best. So let me just say, thank you. I was going to say, if anybody wants to help me figure out how to get all this stuff onto the website, come join the Discord, codingtrain.com/Discord. If you want to support the work that I do, there's 2 great ways to do it. One would be to buy the Nature of Code book. Another way is you could sign up for Nebula. Go Nebula. I think it's here. Let's see if this still works. Yeah. All these videos will also be on Nebula ad-free, so you can go to go.nebula.tv/codingtrain. Nebula is amazing and has all sorts of original content and wonderful curated selection of YouTube videos. You won't find, you won't have to navigate through the AI slop there. Those are things that I'll say. I need to have a talk with people who have signed up for YouTube memberships and the Patreon, which sort of is still lingering there. I do not think it is realistic to do a sticker mailing this year based off of, my time, how long and complicated and expensive that was last year, how I can't get anything to anybody internationally, who knows what tariff nonsense is going on. So it still says in all those places, if you sign up, you will get stickers in the mail. I'm going to have to figure out some type of digital sticker to send to people and hopefully continue to hand out stickers to supporters and people when I meet them in person. But if anybody has any thoughts or feedback about that, let me know in the Discord, which, So I got to go. I want to like hang out and chat and answer questions, but it's been 4 hours. See you on next Monday. There won't be a live stream. I don't know what I'm going to do. Hold on. Just give me a second here. You stay there. You could go, but just for my own edification, I can't believe I'm going to sign out here. No, don't clear the session. I want to sign out. No, don't clear the session. How do I sign out? I guess I can't. You know what? Forget that. I'll figure it out later. I'm going to go. Okay, goodbye, everybody. See you next time. I'm going to press finish. No outro. I'm stopping with all the outro music stuff. It takes too long. Okay, goodbye.